Okay, in the first part we talked about the product of two powers, and in part two of the lesson, we're going to talk about the quotient of two powers. Now remember, quotient is the answer when you divide. So what we're going to do is we're going to get out our dice again, and we're going to roll 3 dice. And that's what the students did in class. We have to make sure that the higher power, the number that we roll for our power numbers, or sorry, for our exponent numbers, the higher one always has to go on the top. So we'll do a couple here. So say we roll, and we get 2 as our base. Quotient is the answer when we divide, so now we're dividing. And say we roll a 5 and a 1. Okay, so I'm going to put a 5 here. The higher exponent always goes, will always go on the top of our fractions for grade 9 and grade 10. The higher number can go on the bottom or the top, but for grade 9, the higher number of the exponent has to be on the top. So when I write this in expanded form, I'm going to get 2 times 2 times 2 times 2 times 2, because there's 5 of them, and then there's 1 on the bottom. Okay, so what you're going to do is you're going to cancel out one of the 2's. Like if you reduce it to lowest terms, the 2 on the top and the 2 on the bottom actually cancel out. So you're going to have 2 to the power of 4. Okay, so there's 1, 2, 3, 4. Just like here on the first example, this 5 will cancel with that 5, and that 5 will cancel with that 5 when you reduce the fraction to lowest terms. So this should be 5 to the power of 2. Let's just do a couple more examples to see if we can find a pattern. So say we roll a 3. Again, we're talking now the quotient, so we have to divide. And say the bigger number was 6, and the smaller number was 4. Okay? So if we write it in expanded form, we have 6 threes on the top. Am I going to run out of room? 1, 2, 3, 4, 5, 6. And we have 4 threes on the bottom. Remember that power is just a short way of writing repeated multiplication. So now I'm just going to change my color to red. I can cancel this one and this one because that will reduce your fraction to lowest terms. That will reduce. That will reduce. And same thing with that one. So really, we are left with 3 times 3, which another way we can write it is 3 to the power of 2. Okay, so let's look at our exponents. We have a 4 and a 2, and we end up with a 2. We have a 5, we have a 1, and we end up with a 4. We have a 6, we have a 4, and we end up with a 2. So pause this video and write down what you think the rule is, or what do you think the pattern is. Okay, so if you put something like subtract the exponents, you're pretty bang on. So what you do is when you divide powers and you have the same base, then you would actually just subtract the exponents. You don't have to write it in repeated multiplication form. So what we're going to do is we're going to learn our law. So instead of writing repeated multiplication to help simplify quotient expressions, we can shorten it by subtracting the exponents. Now again, you have to remember that we have the same base here. Okay, this doesn't work if our bases are different. And again, you can write it with a divide sign, or you can write it in fractional form, because that right there means to divide. So x to the power of m over x to the power of n is equal to x to the m minus n, because all we do is subtract the exponents. Now here it says that x can't equal to 0. That's because you can never ever have a denominator equal to 0. Okay, so that would be the answer to the question. You can never have a denominator. You can't divide by 0, so therefore 0 can never be on the bottom. It can be on the top, it just can't be as your denominator. So if I want to write 10 to the power 7 over 10 to the power of 2 as a single power, I can write it in repeated multiplication form and cancel out. And know that I'm left with 1, 2, 3, 4, 5, or another way I can write it is 10 to the power of 5. Or I can just subtract the exponents because the bases are the same. So 10 to the 7 minus 2, which is 10 to the 5. So exact same thing. It doesn't matter if your bases are negative. So if I have negative 5, remember the brackets indicate that the negative is part of the base. So I have negative 5. And if I want to write it out in repeated multiplication, I have 1, 2, 3, 4, 5, 6, 7, 8. And then I have 6 on the bottom, 1, 2, 3, 4, 5, 6. So when I reduce this fraction to lowest terms, I cancel out all the like factors, and I'm left with 2. So another way I can write that is negative 5 to the 2, or you can write it in shortened form. Since your bases are the same of negative 5, all I have to do is subtract the exponents. So I would probably pause the video and then come back, like do these questions, and then come back and just check your answers. So again, here we have 2 powers. We have the same base. So all we have to do is subtract the exponents. So 12 minus 3 is 9. In B, let's just put a 1 in there so we don't forget about it, because that's the identity power. Bases are the same. I subtract the exponents, and I get 11 to the power of 8. Once again, it doesn't matter if your bases are negative. The brackets indicate that the negative is not a subtraction, it's actually a negative, and the base is negative 12. Bases are the same. We must still keep those brackets around our base. 4 minus 3, and I get 1. Okay. So I'm going to simplify. Oh, okay, no, I'm going to continue on, and then I'll go to part 3 of our video. So you can actually use 2 laws in the same question. So here, for example, I can write it as repeated multiplication. So I have 5 negative 2's, 1, 2, 3, 4, 5. I'm multiplying it by 1 negative 2, and there's that one. Okay, and then I'm dividing it by 2 negative 2's. So if I was to write this in repeated multiplication, that's what I would get. And then I would cancel out my like bases. Oops, one too many. Okay. So now I'm left with 1, 2, 3, 4. So negative 2 to the power of 4. Remember, keep that negative in the brackets. It's part of the base. Or if I want to use my power laws, oh, and I'm frozen. There we go. Okay. Or if I want to use my power laws, I'm multiplying powers with the same base. I add the exponents. I'm dividing a power with the exact same base, so I can just subtract the exponents, and I get the same answer. So it doesn't matter which way you complete the question. You can write out the repeated multiplication and get the same answer as if you use the laws of exponents. So let's try this one. So I'm multiplying powers on the top, or the numerator, and multiplying powers on the bottom, or the denominator. So if I write it in repeated multiplication, I have 1, 2, 3 here. I have 5 more. I have 6, 1, 2, 3, 4, 4, 5, 6, and I have 2 more. So now once I cancel everything out, let's see what happens. Oh, look at that. Everything cancels. So now, remember, we're dividing. When everything cancels, it's equal to 1, not 0. Okay? It would be like saying if I have 3 divided by 3, I'm going to get 1, because these two cancel. Okay? So don't get confused over that. Oh, and I didn't write it in the other form. So I'll do it here for you. Or maybe did I do it on the other page? Nope. So I'll do it here for you. So if I have 3 plus 5 on the top, and I have 6 plus 2 on the bottom, I get 8 over 4 to the power of 8, which is equal to 4 to the power of 8 minus 8, which is equal to 4 to the power of 0. And we know that anything raised to the power of 0 is equal to 1. Okay? So that's how you would do this question with the laws of exponent. So we add them on the top because we're multiplying powers with the same base. We add the exponents on the bottom because we're multiplying powers with the same base. Now we're dividing here. So we subtract the exponents, we get an exponent of 0, so we get an answer of 1. 3 different power laws. Okay, so once again, take the time just to pause the video, try these questions on your own, and then return to check your answers. So here we're multiplying powers with the same base. We add the exponents. We divide powers with the same base, so therefore we subtract the exponent. We get an answer of 6 to the power of 1. Another way we can write it, since that's the identity power or identity law, we can just write it as 6. It doesn't matter, I'll accept both. Okay, and we have here 4 plus 4 over, so we get negative 3, 8 over negative 3, 4, and I get negative 3, 8 minus 4, which is equal to negative 3 to the power of 4. So again, make sure you keep the brackets around your base. It changes your answer if you forget the brackets. Now what are we doing? Okay, so I'm going to pause the video here, and then I'm going to continue on to part 3.